So last week, we know that we need to identify the ordinary differential equation. So different ordinary differential equation that I know, how do I find the solution? So far we have already learned separable ordinary differential equation and also linear differential equation. And then next, if you can tell that it is not separable and the equation is not linear, then the other one is called exact. We can check if this ordinary differential equation is exact or not. If it is exact, then we find the potential function, because potential function equals a constant will be the solution. If it is not exact, then we will continue to use other methods. Okay, and what is exact? What does that mean that this differential equation is exact? That means they satisfy this formula. Okay, I have my function of m of xy and also n of xy. Okay, and for these two, if they satisfy this equation, then it is exact. And once it is exact, then the next step, find the potential function. Okay, for example, for this example, first we need to determine the m and also the n function. Okay, so you need to compare it carefully. Okay, so here we know that dx, the m is minus 2x minus exponential sine y. And also n is e to the x times cosine y plus 1. First, we need to check if it is exact or not, okay, satisfying this equation. Partial m, partial y. So partial m, partial y will get what? Plus e to the x cosine y, right? And then second one, partial n over partial x. Partial n over partial x. It should be e to the x cosine y. Correct? Because here. All right. I only take the derivative with respect to x. And here I take the derivative with respect to y. And they are equal. So now, since they are equal, I know this differential equation is exact. And then now I need to find the what? The potential function. Okay? So how do I find the potential function? We know that the potential function, we say we have a potential function y. And then they also satisfy those equations. Partial phi over partial x will be your mx. Partial phi over partial y will be your nx. Okay, so now I have these two equations. All right? The next, I will choose the green one first. You need to solve the potential function. Okay, so you can either choose the m function or n function. So first, let's choose m function. So the m function, partial phi, partial x. We know this is m. Okay, so what is m? The n function is so here I have minus 2x minus e to the x sine y. Okay, look at this function. Partial phi of partial x equals here. Then I can take the integration to get the potential function. So the potential function, you take the integration. Okay, and this integration you can also think about that the partial x will be here, like a dx, here d phi. So you take the integration. All right. Then you get, I only take the integration with respect to x. Then I have minus x squared plus e to the x sine y plus a function, constant function of y. Okay. Any questions so far? Now I have this phi function, potential function. Okay, I can bring it back to the purple equation. So for the purple equation, partial phi, partial y. We know this is a function of n. Now we can bring the potential function here. What is our potential function? Partial, we just get here, minus x squared plus e to the x sine y, and also a function of y. And then partial y. Okay. Then next, let's take the partial derivative. First term, 0. Second term, sine becomes cosine. So there will be e to the x cosine y. And then this C1 part, I will get C1 prom y. Okay. And we know partial phi of partial y actually also equals exponential x times cosine y. So it should be equal. Okay. So this should be equal. Any questions so far? Then we can compare these two equations. Where? Oh, here. Okay, so we can cancel out. Then we have a C1 prom equals 1. So C1 prom equals 1. That means this C1 function is y plus a constant. And then we have our potential function, because our potential function is here. So our potential function will be minus x squared plus e to the x sine y plus c. This is just the potential function, okay? This is not the answer. Okay, any questions so far? First, we chose the green function, the m, okay, to find the potential function. Then you may ask, why do you need to choose the green first? Can I choose the purple one, the n, to find the potential function first? So let's see. If I choose partial phi, partial y, this is n function. Okay, for this n function, we know it is e to the x cosine y plus 1. And then what here, okay? And then you can put the dy here and then take the integration. So your potential function will be e to the x cosine y plus 1 dy. Okay, this is your potential function. Then you have e to the x sine y plus y plus a constant function of x. Okay? And then you can bring this potential function to the green equation, okay, with m. So partial phi, partial x, that is m function. And it is, since we have the potential function already, so this potential function is partial e to the e to the x sine y plus y plus c2x partial x. Okay, so the first term, I will get e to the x sine y. Okay, e to the x sine y. The second term, no x, okay, 0. The last term, I have c2 prime. And this should be equal to here. So they should be equal to minus 2x minus e to the x sine y. And then you can compare. So the c2 prime is minus 2x. So your c2 function is minus x squared plus a constant. And then your potential function is e to the x sine y plus y minus x squared plus c. All right? So now I just found the potential function, right? This is the potential function. This is not the solution. So here's the note. The potential function is not a solution. What is the general solution? The general solution should be the potential function equals c. That is the general solution. Okay. Okay, here we have 3 questions. Okay, please find the general solution. Okay. You need to check if it is exact, then how do you find the solution? Let's give you, for each team, 10 minutes. So I gave you the answer that you can check later. Right. This you should get 2x cosine x plus y equals a constant. This one not exact, so I cannot find the answer. And the last one, x e to the y minus y equals c. What if it is not exact? That means it is not separable, it is non-linear, and also it is not exact. How can we find a solution? So if it is not exact, next, let's talk about the integrating factor. I still have m function and n function. Okay. Then if it is not exact, I can let this equation to be exact as I times this integrating factor mu. If I times mu and I have a new differential equation and this is exact, then I can find the potential function, and then the potential function equals c will be your answer. It will be the solution. Okay. So I will say this becomes your new m. This is your new n. So those two are well, this equation is exact. That means partial your m new divided by partial y should be equal to partial n new divided by partial x. Okay, let's bring the integrating factor mu here. So partial mu m divided by partial y should be equal to partial mu n divided by partial x. Remember that mu is a function of xy, and your m and also n are also a function of xy. So when you take the partial derivative with respect to y, let's have a chain rule. So first I have a mu, and I take partial m over partial y. And then I take the derivative of the first term, so partial mu, partial y times m. That means mu partial n over partial x. And here partial mu over partial x and capital N. So now let's rearrange this equation. Okay, I put everything related to mu, or as a function of mu, on the left hand side. So I have here n over partial x. And the right hand side minus partial mu divided by partial y m plus partial mu partial x n. Okay. Any questions so far? We assume that this integrating factor mu is a function of xy. Now let's simplify it, that if this mu of xy is just a function of x, let's see what happened. So if this mu function f of xy is just the function of x, that means partial mu over partial y is 0. And then partial mu over partial x, actually that is the d mu over dx. Okay. Bring this back to here, or even to here. Then you have, well, let's bring this back to here. So the left hand side is still the same, mu partial m over partial y minus partial n over partial x. Then the right hand side, since this is 0, I only have the last term, partial mu over partial x times n. Now suppose this n is not 0. Then we can divide by n. So 1 over mu, d mu over dx. That means I put mu to the right hand side. Okay. That'll be equal to 1 over n partial m partial y minus partial n over partial x. And you will see that this is a function of x. And you will see that this function will be, this will be a function of x. And since this is a function of x, then this differential equation is separable. So this is separable. Then we can find the integrating factor mu. Okay. Then of course you may ask, okay, then how about mu? If I say the mu is just a function of y, do the same thing, then here there will be a function of y. Okay. We will do this example, then you will know how to use the integrating factor to find a solution. Okay. Any questions so far? Now, if you don't have any questions, then here is the example, right? So first, let's check the m and also the n. So m of xy. So what is m here in this case? Anyone? X minus xy and minus dy over dx. Then what is m? X minus xy. And then what is n? N in this case? Minus 1. Then we can check if it is exact or not. Okay, partial m over partial y. That is minus x. Minus x. You can also see that this is a function of x. And partial m over partial x will be 0. So they are not equal. Okay, so it is not exact. Now, if it is not exact, then we need to find the integrating factor. Hopefully, we can find the integrating factor to make this new equation exact. Okay, so we will times the mu. All right, and when we times the mu, then we can simplify it to here. All right. So you get 1 over n times partial m over partial y minus partial n over partial x. That is minus x over n, and then this is a function of x. Then suppose we have an integrating factor. We have a mu x. Okay, function of x only. So if I times mu to the original equation, again, this is the new m. And here is the new n. So we can check the partial mu of x times x minus xy partial y. There'll be minus partial mu of x partial x so you have minus x mu of x equals minus the mu over dx so x dx equals 1 over mu d mu. Then you get 1 over 2 x squared will be equal to natural log of mu. So your mu is exponential to the 1/2 x squared. Then you can check this mu times the original function, and this function is exact. This is exact. Then since it is exact, then we need to find the potential function because the potential function will be your answer. Okay, so what is your potential function? What is the new m? Okay, here's the new m. And this is the new n. So let's write it down. Your m new. That's e to the x squared over 2 times x plus minus xy. And this should be partial phi over partial x. And n new is minus e to the 1/2 times x squared. That is equal to partial phi over partial y. Okay, then which one do you want to choose to find the potential function? Either way, but we can choose the easier one, right? It looks like this is easier. I only have x, and here you have like x and also the this correlated term. So if I choose this, I can find my potential function is minus e to the 1/2 times x squared y plus the function of x. Okay? Then we can bring this potential function to the m new. Okay, to find the constant of x. Go back. Okay, if I have a star for this equation, so we can take this potential function to our m new. So partial phi over partial x. So partial x, you have c prime minus xy e to the 1/2 times x squared. And your m new is e to the 1/2 times x minus xy. So compare, you compare the right hand side and the left hand side, you have c prime. That's x times e to the 1/2 times x squared. So your c function of x is e to the 1/2 times x squared. Then your potential function is minus e to the 1/2 x squared y plus e to the 1/2 x squared. Remember that this is your potential function. Then what is your general solution? So the general solution phi potential function equals c. Again, then here you can plus k. All right, but overall, they will combine. So here that means 1 minus y e to the 1/2 x squared equals c. So y is equal to 1 minus c times e to the minus 1/2 x squared. So here's the note. For the integrating factor, here we say that the mu could be just a function of x only or a function of y only. But actually, this mu is a function of xy. And it could be x to the a, y to the b, or x to the a, e to the by, or e to the ax times y to the b, or e to the ax plus by. You can also guess using this using these options to see if the function is exact. And once you use this or more than that, you still cannot find the exact ODE. That may happen. So you may never find an integrating factor. Okay. You may not find a solution. That happens a lot. But sometimes you may have a spatial equation. With this spatial equation, again, that we can use some spatial method to find a solution. For example, the homogeneous equation. If this equation is homogeneous, then you can use you can use changing variables to find a solution. But what is the homogeneous? What does homogeneous mean? So if the differential equation is homogeneous, that means you will see this form. Y prime is a function of y over x. Okay, if you see the equation with this form y over x, this is homogeneous. That means the y prime will be equal to any combination of y over x. For example, is this homogeneous? Well, here I have a y over x. Well, even though this is x over y, but you can take the reciprocal. So you will get, this is also a form of y over x. Okay, so this is homogeneous. The second one, is it homogeneous? Did you see any form of y over x? Impossible, right? And what is this? Can you find a solution? Which type of this differential equation is? Any thoughts? I thought this is obvious, right? We only learned three types of equations. Is that exact, a linear, or even separable? I think it's separable, right? You can put y here, x. But this is not homogeneous. And how about the last one? Is that homogeneous? Well, we don't have the y over x term, so this is also not homogeneous. But if x is not 0, okay, so if x is not 0, then in this case y prime will be y over x divided by 1 plus y over x. And here you can see that this is the form of y over x. So this is homogeneous. under the condition that x is not 0. So if you can find this is the homogeneous differential equation, we can use changing variables. So what does that mean? Change the variables. So change of variables. Say this time u equals y over x. So if y is equal to ux, that means y prom will be u prom x plus u. Okay, so this will be the function of u. Then we can rearrange this. So 1 divided by f of u minus u du will be 1 over x dx. And you can see that this is separable. And since it is separable, then you just take the integration, then you can find your u. Once you find your u, go back. Done. Okay. Let's see an example so you know that how do you use the change of variable. Okay. First, this equation, is that homogeneous? Like we have a form of y over x. Looks like no, but if x is not 0, that's just divide by x from the both sides. Then we have y over x squared, and here y over x. So if I divide by x, and also x is not 0, okay. So dividing by x, we have y prom equals y over x squared plus y over x. And this is homogeneous. And of course, you need to say that x is not 0. Then our answer actually just y equals ux, not mu, so it's u. So my solution, well, is also y over y equals ux, and we need to find u. So u prom x plus u will equal to u squared plus u. Why u squared plus u here? Okay. Then you have u prom x equals u squared. 1 over u squared du will be equal to 1 over x dx. And then you take the integration. Minus 1 over mu u will be natural log plus constant c. So we know that the u is minus 1 over natural log x plus c. And your solution, y is ux. So minus x over natural log x plus c. That is your general solution. Okay, quite easy. If it is a homogeneous differential equation. So let's practice. I have a x dx plus y minus 2x dy equals 0. Find a solution. And also y dx equals 2 times x plus y dy. Okay, you can check if it is homogeneous. If it is homogeneous, then what is the solution? Okay, let's do that again. I'm give you the references answer. Okay, you can also practice and check. It should be x plus 2y equals cy squared. X minus y natural log x minus y equals c x minus y. Okay. So this is the case for homogeneous equation. We have still some special first order differential equation. The next one is called Bernoulli equation. So if you find out the form like this, and this will be the Bernoulli equation. And once it is Bernoulli equation, let's see what's the method to find out the solution. Y prime plus p, the function of x times y, and also the function of r times y to the alpha. Okay? And alpha is a real number. First, if alpha is 0, okay, alpha is 0, nothing. And what is this? Y prime plus p of x y equals a function of x. Is this what type of differential equation it is? Separable, linear, exact, or even homogeneous? Linear, right? So if it is linear, then also you need to find the integrating factor. Okay, so when alpha equals 0, this is linear. And how about alpha equals 1? If alpha equals 1, is that linear, separable, or exact? Which one? Separable, right? Because here's y. So I can have y prime equals a function of x times y. So when alpha equals 1, it is separable. If it is not 1, then Bernoulli equation, we need to learn. Here we have another variable. We still do the changing variables. Okay, so another variable called mu. There'll be y to the 1 minus alpha. Okay, so still change of variable. So if we let mu equals y to the 1 minus alpha, and then bring it back to the original differential equation. Let's see. So here, well, we need to compare. Okay. So the px is 1 over x, right? Then what is alpha? Alpha is what? Alpha is 3, right? So here, alpha is 3. That means my mu is y to the 1 minus 3. So it should be y to the minus 2. So now I have to change the variables, which means y becomes mu to the minus 1 half. And since y equals mu to the minus 1 half, y prime will be minus 1 half mu minus 3 over 2 mu prime x. Okay, so now we have a y prime. We have a y. Bring it back. When you bring it back, you have minus 1 half mu to the minus 3 over 2 mu prime x plus 1 over x, and your y is mu times minus 1 half. That equals 3x squared, and y cubed will be mu times mu to the minus 3 over 2. And you rearrange it. Mu prime equals minus 2. Mu prime minus 2 over x mu. That will be equal to minus 6x squared. And then you can see that why we use mu equals y to the 1 minus alpha, because after changing variables, we have a linear differential equation. And once this is a linear differential equation, we need to find the integrating factor. And if you forget what linear integrating factor is, or you want to review the previous lecture notes or lectures, you can see that on NTU Cool we have the video for that, so you can watch that video. So here we should have exponential minus 2 over x dx. That gives you x, 1 over x squared. So once I have the integrating factor, bring this times this integrating factor to your differential equation, then you have x to minus 2 times mu prime minus 2 times x cubed minus 3 times mu. That should be equal to minus 6. So overall, we have x to the minus 2 mu prime. But overall, we take the derivative. That will be minus 6. So x to the minus 2 mu will be minus 6x plus constant c. Then your mu is minus 6x to the x cubed plus cx squared. That is only your mu. And then your y, which is also your solution. Remember that for the solution is mu to the minus 1 over 2. So there will be a square root 1 divided by cx squared minus 6x cubed. Okay, so here is the example for the Bernoulli equation. So once you change the variables, then you can get the equation to be linear. Remember that for the homogeneous equation, I also use changing variables to get the equation separable. But for Bernoulli equation, I use the changing variables to get another linear equation. Okay? Any questions so far? All right, if you don't have any question, let's just see another example. So again, you can compare the Bernoulli equation. You can see that what is that? The alpha is 4. Okay, in this case, alpha is 4. Then we just let our nu, that's y to the 1 minus 4. So changing variables, this should be, I will change y equal to nu to the minus 1/3. That means the y prime is 1/3 nu to the minus 4/3 times nu prime. Okay, and then you can bring it back to your original equation. So 3 times y prime, and y prime becomes 1 minus 1/3 or minus 1/3 mu times minus 4/3 mu prime plus mu to the minus 1/3. Okay, and then you rearrange that, you'll get minus mu prime plus mu, that's 1/2x, which means mu prime minus mu equals 2x plus 1, minus 1. This is a linear equation again. So finding the integrating function, integrating factor. E to the, here is minus 1, p is minus 1 dx, which is e to the minus x. Now we times this integrating factor to which equation? This one, okay, the mu function. So e to the minus x mu of x minus nu e to the minus x will be equal to e to the minus x times the original force function 2x minus 1. Remember that using the integrating factor, I can combine these two because the chain rule. So e to the minus x mu to the x. Overall, if I take the derivative, by chain rule, we'll have 2 terms. And the right hand side, just keep the same. And now take the integration. Okay, so mu, I still have e to the minus x. And here I have 2x e to the minus x dx minus e to the minus x dx. Well, for this integration, let's do a quickly review. How do we do this equation, this integration? Integration by parts. So integration by parts. What is the integration by parts? U dv equals uv minus v du. For example, x d e to the x, that is x times e to the x minus e to the x dx. Okay. So here we have minus 2x d e to the minus x. Okay, so the first term here becomes minus 2x e to the minus x minus 2e to the minus x dx. A second term minus e to the x minus x plus constant c. So overall, you'll get minus 2x e to the minus x minus e to the minus x plus c. Remember that is still your mu x times e to the minus x. So now you can change the mu back to y. So y to the minus 3 times e to the minus x is minus 2x plus 1 e to the minus x plus c. So y to the minus 3 will be minus 2x plus 1 plus c times e to the x. Okay. All right, then that is the Bernoulli equation. And you can still check xy prime plus y equals 1 over y squared. And xy prime minus 1 plus xy equals xy prime. And try to find your general solution. Next spatial one is called, and also that it should be xy squared. Okay, here xy squared. The next equation is called Riccati equation. Okay, Riccati equation. And for this Riccati equation, we have this format: y prime equals p, the function of x times y squared, and the function of q, function of x times y, and also r of x. In that case, this is called Riccati equation. And how do we solve this Riccati equation? First, if the p of x px is 0, so suppose this is 0. Okay, so this is 0. What is this equation? Y prime equals qx times y plus r of x. Is this separable? Is it exact? Is it linear? Or none of them? All right, so if px is 0, then this equation is separable, or linear, or exact. Which one? Linear. Yeah. So this is linear, which means You need to find what? To find the solution. You need to figure out the integrating factor to find the solution. Okay. If Px is not 0, then this Riccati equation, we have the solution y. That is the Sx plus 1 over z. And we need to find z. And then what you may ask, then what is S of x? The S of x, we call that particular solution. And normally we will guess, or by the observation. For example, okay, here we can see that the Px is 1 over x, Q of x is 1 over, also 1 over x, and Rx is minus 2 over x. So since the Px is not 0, it is not linear. And then this is Riccati equation. Then our solution should be the particular solution plus 1 over z, and we need to find z. And for this problem, by observation, we can see that y equals 1 is a solution. Y equals 1 is a solution. Obviously, right? If we put 1 here, 1 over x plus 1 over x, that's 2 over x. Minus 2 over x, that's 0. And since y is a constant, y prime is 0. So actually y is a solution. So by observation, you can get a particular solution. Then your overall general solution is 1 plus 1 over z. Or since your solution is 1 plus 1 over z, then bring this back to the original differential equation. You will get y prime x. Y prime x will be minus 1 over z squared, z prime. Okay? So that is, let me write it down again. So y prime equals 1 over x, y squared. Y is 1 plus 1 over z squared. And also the second term, 1 over x, y is 1 plus 1 over z, minus 2 over x. Then let's rearrange this. You have z prime, z prime plus 3 over x z. That equals minus 1 over x. This is another differential equation, right? Since it is a differential equation, you always have to ask yourself, is that separable? Is that linear? Is it exact? Because if this equation satisfies one of these three types, then you know how to find a solution. Okay, so first, is that separable? Yes? No? Is this linear? Yes, this is linear. Then what do you do once this is linear? Find the integrating factor, right? So now let's find the integrating factor. So what is the integrating factor? Exponential to the integration over px. You get x cubed. So now let's times the integrating factor. Z prime times x cubed plus 3 over x z times x cubed. That's equals 1 over x minus 1 over x and also x cubed. Remember that why do we need the integrating factor? Because this part I can combine. Why do we have these two terms? Because when we do the chain rules, we'll get the two terms. So what is the, before the result, what is the original form that we need to take the derivative to get these two terms? That's x cubed z prime. Right. Take the first derivative, keep the first term, take the derivative of the second term, plus taking the first term, the derivative of the first term, and keep the second term. Okay? Then you have z x cubed equals minus 1/3 x cubed plus a constant c. Then you get your z. Okay. Then you just get your z. Okay, z is not your solution. Remember that your solution is y equals 1 plus 1 over z. So your final general solution is okay, well, let's rewrite that. It could be k. Okay. Any questions about this? Okay. Now next, today we will finish our first order differential equation. Okay. So far, we find the solutions, but don't you think that when you find a solution, is that the solution just unique? Or probably there are so many solutions, you just find one of them. How do you verify that? And how do you know that, okay, actually they have the unique and only one solution? So let's see the existence and uniqueness. If we have the consider the initial value problems, okay, we have the initial conditions. Will we get just one solution or more than one solution, or even there's no solution for this differential equation? For example, y prime equals 2 square root of y, and here's the initial condition. So if y is not 0, then let's see, it is separable, right? Definitely separable. 1 over 2 times square root of y, y prime equals 1. Then you have d dx square root of y is 1. So you get square root of y is x plus a constant. And your c, again, c is an arbitrary constant. And then we can use the initial condition y of 0 equals 1. Then your c is square root of minus 1. And you see that this is square root of minus 1. It is not a real number. Not a real number. And my equation is real. So actually, I can get this solution here so far, that's okay. But for the initial value problem, we cannot get the real solution. So the initial value problem has no real solution. And also that means if the initial condition y of 0 is less than 0, the y0 is less than 0, then no solution. And how about initial condition y of 2 equals 0? Y of 2 is 0. Then we get y equals 0, a trivial solution. And if we bring this to the solution and get to find the constant c, then you will see the square root of 0 equals 2 plus c, and then your c is minus 2. That means your solution, square root of y equals x minus 2. Then your y actually is x minus 2 squared, and your x should be greater than or equal to 2. Which means for this initial condition, I have at least 2 solutions. So without the initial condition for this differential equation, okay, we can find a general solution. But once we have an initial condition, the initial value problem may have no solution. Or more than 2 solutions. More than 1 solution. It really depends on your initial value. Okay, because so far we just find a general solution, and you see the general solution we also have a constant. To determine the constant, then we need the initial value, initial condition. Okay, but depends on your initial condition. You may have finally no solution, or 1 solution, or even 2 or more solutions. Okay? Any questions?